So let's solve an example on line integrals. When I integrate the function x plus y plus z divided by x squared plus y squared plus z squared over the curve C, and we're given the parameterization of the curve, and we're also told that t ranges between a and b. If you take a look at this function here, you see it's a scalar function and not a vector field, therefore we know that this is going to be a ds type line integral. And if you remember the steps, the first one was to parameterize, and the second was to substitute and evaluate. So let me write down the formula. Okay, so for this specific problem we don't have to worry about step number 1 because we're already given the parameterization of the curve. We just need to find the values and substitute into the integral. So if you take a look at the parameterization, that's the x component, that's the y component, and the z component. So we can find dx by dt, it's going to be equal to 1, dy by dt is equal to 1, dd by dt is equal to 1, x of t is t, y of t is equal to t, and z of t is equal to t. So let's substitute this into the integral. The function was x plus y plus z, so we get t plus t plus t divided by, we had x squared plus y squared plus z squared, so we get t squared plus t squared plus t squared multiplied by dx dt squared, so we get 1 squared plus 1 squared plus 1 squared dt. So if you simplify this, you get 3t divided by 3t squared multiplied by the square root of 3 dt. So you see here the 3 cancels, this t cancels the square, and we end up with the integral from a to b, square root of 3 over t dt. We can take the square root of 3 outside since it's a constant, and we're just integrating 1 over t. So this is going to be equal to 1 over 3 times ln t evaluated in b and a, which is equal to root 3 times ln b minus ln a, and we can simplify this by saying that's equal to root 3 times ln b over a, and that's the final answer.